Assalamualaikum and hello everyone. My name is Muhammad Haris Luqman bin Muhammad Khairi and my number matrix is CF220224. So, without wasting time, I will go through the first part of our presentation, which is introduction. A storm water drain is infrastructure designed to drain excess rain and groundwater from impervious surface such as paved streets, car parks, parking lots, footpaths, sidewalks and roof. Storm drains vary in design from small residential dry wells to large municipal systems. Drains receive water from street gutters on most motorways, freeways and other busy roads as well as towns in an area with heavy rainfall that leads to flooding and coastal towns with regular storms. Even gutters from houses and buildings can connect to the storm drain. Many storm drainage systems are gravity sewers that drain untreated stormwater into rivers or streams, so it is unacceptable to pour hazardous substances into the drains. However, storm drains sometimes cannot manage the quantity of rains that falls in heavy rains or storms. Because of this, in this presentation, my friend, I will show why the current drains in the study area are unable to handle a significant volume of water during heavy rains as well, and we will discuss what the best solution for solving this issue. Okay, I will continue to this part, which is study area. So the study area has been set in rubric, so we just following the rubric instead of map it anywhere. So the study area is at Taman University, Parit Raja, Batu Pahat. So the current drainage system by the main road is 408 meters long, 2.3 meter deep for wide, 5.35 meters for top width, 4.95 meters for base width, and has an average slope of 2.15 meters. So that's all from study. As you guys can see, this picture is taken from Google Earth and we take based on location that been set in rubric. For the problem statement, we obtain three problems that occurs which is size of the flow channel is not suitable for the area and needs to be analyzed precisely in designing the stormwater drainage system. Drains that don't properly eject water into the catchment area and drains are unable to retain a lot of water. Because of this, the undesired thing will happen, which is the drain fails to work and will cause problem for all of us. Therefore, we have proposed a new design to replace the old one. Okay, for the last part of my presentation is the objective. Like you guys know that objective must related to problem statement. So for our objective is propose an appropriate drainage system that may successfully lessen the heavy flow, determine the reason why the drain water is not draining properly, and determine the reason why the drain cannot retain a lot of water. Finally, hopefully this layout of our objective can answer the problem statement. Okay, that's all from me, and I'll pass this presentation to next presenter. Thank you.
For the next is methodology. In this assignment, the task was to complete drainage design manually in part of Taman University Parit Raja area. We need to propose a suitable drainage design perfectly. A suitable analysis method was used to design the area climate and condition. Other than that, at this site survey, our team concluded that the area was a grass drain with a tall grass, which is grass cover more than 150 mm. The meaning roughness is 0.050. Okay, for the next is dimension and area of the drainage. The drainage was a trapezoidal drainage with and the area is 22.76 meter, or the Z value is 2.15, perimeter is 10.40 and R is 2.19. Okay, for the last part of methodology, there are what we conclude in this project, which is the friction slope, empirical IDF curve, the peak flow, the meaning roughness and the dimension and area of the drainage. This calculation will show at the analysis data.
Hello, my name is Alexander Maxwell Argument and my card metric is CF220101. In this slide, I want to talk about the diagram that we got the data from the site visit. For the top point is 5.3 5 meter, the height is 2.3 meter, and the bottom height is 4.95 meter, and the jet we can calculate, and jet is 2.15. In this slide, I would like to talk about the calculation for existing drainage channel. From the site visit, we know that the gas is about 150 mm, so the coefficient thickness is 0.05. Then we need to go to the number 2 to find the hydraulic radius. First we need to find the area and then the perimeter weighted. From the calculation, we got 22.76 meter cube and 10.4 meter respectively. So we divided it, A divided to P, we got the answer 2.19 meter. And then into the number 3 for the equation 2.1 for friction slope, first we need to find the lowest elevation and highest elevation from the Google Earth Pro. We get the highest is 32 and the lowest is 25, and then we change it to into the unit of meter, and then divided it with the length of study area 456 meter, and then we got 0.047. Into the number 4 from the table 2.1 trouble time in drain, we got the answer 3.29 minutes, and then we need to calculate the storm duration D 3.29 divided with 60 because 1 hour is 60 minutes. So the answer we got is 0.048. Then into the number 5, we calculate the IDF air pressure volume for state, station ID and station name. So for the state is Johor, station ID is 1829002, and then for station name is Shetor JPS Batu Pahat. Then from the table we can find the 4 constant value to calculate in the number 7 for equation 2.2. So for the number 6, we find it in the table 1.1, the quantity design storm RI. So we could the measure about 100 years, so the T is 100. And from the equation 2.2, we calculate from the from the collected data in the about number 1 into under number 6. So we use the formula, and then we got 440.48 mm per hour. In this diagram, we can see the proposed drainage channel that we choose. For the top height, we got 6.5 meter, the bottom height is 5.2 meter, and the height is 3.0 meter, and the depth is 1.73. In this slide, I would like to talk about the calculation for proposed drainage channel. For the roughness coefficient for this drainage, we design it 0.035 because we said that the short grass cover is under 150 mm. Why? Because to make the floor is smooth. And then for the area, for the second two area is we find it 31.17 meter cube, and the perimeter weighted is 11.19 meter. And from this we can calculate the hydraulic radius 2.79 meter. And then for the number 3, 4 and 5 and 6, we design it sum as the existing drainage channel. And then into the number 7, we can calculate from the value of R because this proposed drainage channel we change it. So for we can get the answer is 474.61 meter mm per hour. In this slide, I would like to talk about the peak flow for existing and proposed drainage channel. In the proposed existing drainage channel, we get the runoff coefficient C from the table 2.5 is 0.95. So we calculate the discharge we get from the equation 2.3. We calculate it equal to 26.46 meter cube per second. And then from the proposed drainage channel, for the runoff coefficient is still same, 0.95. So we calculate the Q, we can find it 28.51 meter cube per second. So this means that the proposal of new design of drainage channel is passed because the Q proposal is higher than the Q existing.
Hello and Assalamualaikum. My name is Muhammad Azrul Shazwan bin Syarul Anwar and my metric number is CF22147. So today I would like to talk about discussion for our project. So as we did the calculation, we found that the new flow design of the discharge was found to be higher than flow peak of the discharge, which means that the proposed new design of the channel section is a pass. Not only that, we found that the flow rate of each drainage size is different in terms of length of the channel and its depth as shown in the table below. Why difference? Because when we construct a new design drainage, we want to avoid that flood keep happen in the future. However, the value of existing drainage for the proposed drainage channel is different because we see the grass growing taller than the old drainage. So due to the difference in the end value, there will be effect at value at intensity between the new channel and the old channel. So for our reference, we use a MASMA second edition to define a sum value to meet the requirement of the Malaysia standard when we design the new drainage. We use also Google Earth Pro to find the area or parameter for the channel because it will be quite harder when we use a measure tape and we just use Google Earth Pro. So next for our conclusion project, this project developed a method for preventing floods at the study location. Determination of the rainfall intensity is a must before constructing the drainage. Not only that, but we also need to know bending roughness, friction slope, intensity, duration, frequency, IDF, and usage type and average interval ARI to calculate the peak discharge of the drainage and also to propose the design of the peak flow on the side drainage. In other words, this project is required to design a new drainage to avoid the flood keep happening. That's all from us. Thank you.